Welcome back to Speed Freak Garage, home of PowerSports on YouTube. This is part 3 of our custom radiator upgrade, so you didn't miss anything. I went ahead and made the prototype radiator mounting bracket for the radiator, oil cooler, and fans. Fabricated it up, made sure it worked correctly, and I wanted to show you guys the final result. So you can see there's a bracket at the bottom to hold the radiator, and then next up is the oil cooler and then the fans. And this has the minimal air restriction. Sorry, this this was a lot of work, so I'm out of breath. There's minimal air restriction throughout this bracket. It's going to hold the radiator nice and strong. There's some tabs on the side for mounting to the frame. They're a little off, but that'll be okay. You can see the tabs here, and on the other side for holding the oil cooler. You can see I have a solid bottom bracket to protect the radiator. So we've basically got a finished prototype. We just need to do a little bit of welding on all the seams where we bent the metal. We need to do some countersinking, and then we need to primer and paint, and we'll have our radiator basically ready to go, and hopefully it works and keeps everything cool. One thing we're adding, we are going to add 2 more fans behind the oil cooler. So we'll have 2 huge 9-inch fans up top, and then 2 small 5-inch fans on the bottom. And basically we'll be able to turn on 1 big and 1 small fan with a single relay and fuse. And then at higher temperature, the other big fan and the other small fan will be able to turn on. So now, if you guys want to stay tuned, I'm going to take you through how I designed this, basically start to finish. It probably going to be quite a bit of long technical, boring, but if you guys want to know how I got to this point, then stay tuned. Okay, so because the 3D scanner was throwing a fit and not really doing what we needed it to do, I just busted out calipers and tape measure and a notebook. And what I did is I measured the overall width of the radiator, I measured the width of the core, I measured the width of the tanks, I measured the distance to here to here, and you can see I actually had to come back and flatten these welds out because I forgot to measure the width of the tank, including the welds. That was kind of a risk doing that. I measured the height of the radiator from here to there. I measured the thickness here. I measured the in-between from here to here, and on the top there to there because it's not perfectly straight. I measured the height, overall height from here to there on the tank. Then I came in, I measured the area of the core on this. I measured the height, including the brackets, overall width, the width and size of the tanks. I measured the slots in relation to the tanks. I measured this hex so I could model it, hoping that I don't have to buy special 90s or banjos. I really don't want to buy banjos, but I might have to for this because it's $60 per banjo, which is a rip-off set trab. Fucking thieves. $60. Give me a break for 1 banjo fitting. Anyway, and then because the 3D scan didn't work, I also measured the bolt patterns on the fans. So I just measured hole to hole to hole, and then I measured the outer diameter of the fan, the inner diameter of the fan, the thickness of the flange, the height, and I put all that into CAD, and then I arranged it onto the radiator just like I showed you guys in the previous video, and then started designing. So we're going to jump over to the computer so I can show you how I designed based off of those measurements that I took by hand. Oh, and always use the calipers if you can. So I had the biggest mine will go is 12-inch. So any dimension 12-inch or less, I used the calipers because they are way more precise, accurate, whatever you want to say, than a tape measure. Alright, and now for the boring part where I'm going to show you guys how I designed this step by step. I did not record myself designing it because it took a little over 6 hours and there's no reason at all to make a video that long, nor would anybody care anyway. So the first thing we did was design the fan. You don't have to have the whole fan designed. So we created a sketch. Of course, it's not going to show it. Created a sketch, mounting holes, inside diameter, outside diameter, and just kind of approximated where these. Ow! Cat just. Hey! Hey! I'm recording a video. Can you stop? Okay. So let's go into the sketch here. So here's my sketch. Got everything in here. Okay, so after that, we just extrude our flange here. Then another sketch, which is just the thickness of the fan, and then we just extrude it up. And that's really the only information you need for the fan. Don't save, of course. Then we went and did the oil cooler, and we used the same strategy. So we created a sketch. The sketch has all the dimensions and everything that we measured by hand. Okay, so then we extrude that out to get our 3D shape. Then we need to draw the mounting holes and these AN ports, or I should say M22 ports. Once those are done, we can cut the holes, extrude the ports, and now we have a pretty good representation of our oil cooler. Don't save, please. Alright, so now the fun part, and I also did import the mesh of the car. There is actually one more step in RevoPoint to get this to where Autodesk could read it. So there is actually a mesh tab, and then in the mesh tab you export to STL. That should be pretty straightforward to figure out, but if not, look it up on Google. And really the only thing that I needed to measure was where the front of the car is, where the radiator touches, to the center of this screw, which came out to 20 millimeters, 18 millimeters-ish. I actually got it pretty close. And then from the center of this bolt to the center of this bolt, which was just 1 inch. Ah! Ah, the cat just dug his claws into my stomach. Okay. He's like, it's dinner time. I'm just gonna leap off his lap at fucking light speed. Okay. So we got some dimensions off of there, and we need, this is good, but it's not good enough, so we'll have to go back and rescan it. But anyway, that's the only thing we needed that for. So I don't know if this program is going to freak out when I go backwards through this entire timeline, but we're about to find out. So the first thing we did, ooh, yeah, it's not happy. It's already not happy. Okay, that was weird. Okay, first thing we did, we created a sketch. We know that the overall width of the radiator is 24 inches wide, and the core of the radiator is 2266 thick. So we do that. We extrude the bottom piece of our bracket and leave it solid for now. Then we create flanges on both sides that are 1.5 inch tall. Those flanges are the same height as the other radiator bracket we're replacing, so we decided not to change that. Then you need to create more flanges over for your mounting holes to mount to the car, and I forgot to do the mounting holes and had to come back and do them later. So then I created a support flange in the back, and this support flange is just for strength. Then we came up here and we created this big front flange, which is going to hold the fans in the cooler. And then we added in our components. And throughout the process, we were turning on and off these components' visibility, so it might kind of mess with us a little bit, but we connected the two fans together with a joint, and then we grounded our bracket so it doesn't move, and then we snapped the fans to the flange. And then we went and drew a sketch, and of course the fans aren't going to be in the correct place now, but
We drew a sketch with the inner diameter of the fans and 1/2 inch off the top, so we have a little space to mount to the radiator. Okay. And then next we cut the holes out for the fans. Basically, you can kind of assume the fans are just there. Whoops, nope, my bad. Then we attach the fans, reattach them to the holes for that we cut out. Then the oil cooler gets attached and centered and down at the bottom here. And then we drew a sketch that outlined the oil cooler. You just use the project function to project that whole face. Okay, we cut away anywhere where we want airflow, and then we flanged over these mounting flanges for the oil cooler. And the reason why they're on the back side is because you cannot cut this out to make a flange. I mean, you kind of sort of can, but that's not really the right way, especially down here, you can't. So we did it on the inside instead of the outside of the oil cooler, but it'll still work just fine. Then we drew a sketch for the mounting holes, and then cut through our mounting holes so they're in the center of the slots on the oil cooler. Give us a little space to work with. Okay. Then we drew a sketch to add some extra thickness to the bottom of our bracket that we forgot. And then we're just adding thickness, and then we're flanging up. And this is going to hold the tanks. And I actually forgot to include the thickness of the welds, so as you saw, I had to grind down the welds. Then next, I fixed, so you can kind of see there's like a gap here. I fixed that gap on both sides. So that way I can come back and weld it closed. And then we created a sketch to do some work here with the fan mounting. So we created a flange, I need to turn the fans back off. Pretty much from here on out, I'm working without any of the other stuff turned on. So I created a flange to support the fans, because this flange makes this way stronger since it's so thin. And then it comes out towards the frame of the car, because the frame of the car is 11 inches from the bottom, and then it's 2 inches thick. Then I created another flange that will drill holes in for riv nuts that'll go into the frame, and that will hold this all stable while we're racing. Because I mean, we're going to be bouncing up and down and just beating the car to death. We'll probably weld in some little triangular gussets once everything is right and we know it fits, to make sure nothing moves. Then we drew a sketch. This sketch is pretty complicated. We wanted some structural support here in the center so it wouldn't collapse inward on itself. We need some supports for the fan. We need the flanges of the fan to be supported all the way around, but we don't want any extra material. I did put some extra here to help secure it to the top of the radiator. So then after that, we cut... Oh, what just happened? There we go. We cut it all out. So we cut everything out that we don't absolutely 100% have to have. And so that's how we got to that point. Then you can see I did my little inner piece here, and it was way too thin. So the next step is to round. You see everything here is all sharp corner, sharp corner, sharp corner. You don't want sharp corners. Those are weak. So we rounded everything with a 6mm radius. I mean, everything, all the corners, here, 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 everything. Again, you do not want sharp corners. Okay, then we drew another sketch and fixed. See how this is really thin here? We fixed this. Now it's 6mm wide, which is just strong enough. Then we radiused it a little better. And then we radiused that. Now we came back. And what is this? What is this sketch for? Ah, sorry, up here. So now up here we need little holes, like little M4 holes, bam, to screw into the top of the radiator so everything stays nice and tight and doesn't rattle. And then the very last thing, I forgot our mounting holes, so I had to go back to that 3D model of the car, the 3D scan of the car, and I measured off the 3D scan of the car 18mm and then 1 inch. and then I just guessed they were 10mm holes, which luckily was a good guess. And it actually fit, as you saw, it fits on the car. So that was pretty cool that the 3D scan was able to keep me from having to walk all the way outside in the rain and walk all the way back in just for 2 measurements. So that was cool. And then we cut the holes. Okay, so this isn't the end of it though. You're just like, okay, so we got a 3D model. Well, I can't just make that. It doesn't work like that. You have to have what's called a flat pattern. And so the flat pattern, you just, let's say for example, I clicked on this and it flattens it out. And then these blue, let me hide all the changes to the flat pattern. It's going to get really mad. Okay, so it comes out with these blue lines, which are your bend lines. However, I don't have a brake press, and even if I did have a brake press, I would not have a finger press, because finger presses are ungodly expensive. I mean, a brake press is ungodly expensive, let alone a finger press. So the only way that I can actually do this is by cutting slits where the bend line is and then bending it by hand in a vise with a hammer and pliers and screaming and yelling at it for several hours, which is what I did today. And again, it took so many hours, there was no point in filming a video about it. I mean, it's just beyond, beyond attention spans. So the first thing I did actually is I cut out this extra chunk here that for whatever reason the computer software didn't cut out. So as you can see, I cut that out because it's unnecessary. It's just in the way of our bend. It would have made it very hard to bend this tab. So then the next thing I did is I cleaned up this error here. So see how there's a straight cut? It should not be a straight cut. Like why? Why is that cut? I don't know, but I fixed it. So you can see I fixed that cut. So that's stronger now also. And then I radiused. I shouldn't have done that. Actually, it made life hell out there today. I should have maybe just done half that radius. It made it a little too strong. But basically, I went through and I radiused anything that was still, not, except for these. These are going to get welded, so I left them. But everything else was radiused. Okay, now to get the machine to cut it, I had to go in and draw my own cut lines. So 6mm from the edge, which I probably should have done a little lower because it was hard to bend. I had to get it in the vise and beat it to death. I could have bent the whole thing by hand if I had maybe done, I don't know, 4mm. Might have been maybe too weak. And you can see I did 6mm and then I think like 2-inch, 6mm, 2-inch. So it cuts out a ton of this so that it's easier to bend. And then, I don't know if this is going to work or not because I did it on my laptop out in the garage. Good. Okay, it's saved. So to manufacture this, you have to go in and create a setup with your plasma cutter or laser cutter or whatever. You tell it how much material you have. Okay. Oh, don't get mad. Okay. And so then basically you go through and you say, okay, I want to cut all these lines. I'll turn the model off. So see, you can see it's cutting these lines out and leaving little tabs for me to bend. Then you want to cut out your inner holes. Whoops. So it's going through and it's cutting all the inner holes out. And it really hates little holes like that. I was having a lot of trouble today. And then you come and you cut out. So you see you got your tabs, inner holes out, and one long outer profile. So now you have a fully finished and ready to go thing. So real quick, it's always a good idea to hit the simulate button and make sure that you're not going to destroy your machine. So you can see it just cutting. Kind of watch it, make sure nothing. I mean, this is way, way, way more important for CNC milling. Like everything I CNC mill, I really, really carefully watch this simulation and look for issues that arise while it's cutting, whether it's, it'll turn red if it detects a collision, or if I see something really dumb or something that's backwards or not in the right direction. But basically, it allows you to see exactly what you're going to see out there on the machine, pending that you have your machine and your program set up. So we can go to top and make sure everything looks good, and it does. We can turn our model back on and compare to the model, make sure that it's right. and it looks right. So exit simulation, and then what we do is we send it to the machine and we cut it on the machine. So I'm going to now switch over to the video of it cutting on the machine so you guys can enjoy that. And that's the end of this video. So part 4, I'm going to try and have everything assembled, painted, and ready to show you the final result. And then eventually I'll have to beg somebody to help me install it in the car, because there's no way I'm going to be able to install it by myself. I really don't want to damage that radiator, which I probably shouldn't install it anyway because we don't have an engine, and the engine has to go in first before the radiator. So that's going to be a mess. Anyway, we're going to switch over to the video of cutting this out. And thank you guys for watching, and see you next time.